For 30 years, automation and flawless performance in machines has been a standard in manufacturing. However, in 1983, there was sheer necessity and harsh economic conditions which generated a rather compelling need for a similar performance at an architectural services firm in Des Moines, Iowa, United States. This is a case study of their perseverance and research that led to the development of a prototype that adapted these machine technologies to enable near flawless and consistent performance in knowledge workers. This innovation and adaptation has worked near flawlessly from 2004 to date. On June 15, 2010, the innovation was awarded a United States patent. In 1952, manufacturing technology was greatly automated but commercially not viable. Just as today's technology permits us driverless cars, however, these are also not yet commercially viable. So, the business and revenue model then and now are indeed compelling for these technologies. So, how was this overcome? Even in those days, a single machine, the numerically controlled machine, did the work of many machines. As we can see from the display below, a numerically controlled machine does grinding, polishing, turning, and more. But if an error occurs in any of the processes, this would be carried forward into the subsequent processes. Manually detecting such errors would require halting the process, removing the component for inspection. This would defeat the purpose of automation. It would be the weakest link in the chain. A defect in any of the processes could only be carried forward. Not only would the machine component be rejected, but the remaining processes would be a total waste. Even more damaging, the subsequent components to be machined would inherit these errors just like prenatal birth defects. Such massive and expensive rejections made the use of this remarkable technology unviable. So, if these unmanageable rejections could only be addressed, this would be a game changer to the manufacturing industry. The business and the revenue models were without any boundaries. Massachusetts Institute of Technology (MIT) was approached to address this problem. MIT introduced artificial intelligence into the numerically controlled machines. This artificial intelligence could now both detect and correct errors as they occurred, preventing errors from being carried forward. This was MIT's game-changing invention. In numerically controlled machines, positioning and cutting instructions were sent directly to the cutting head. However, MIT sent the signals to a controller equipped with artificial intelligence, the servo motor. The servo motor compared the position of the cutting tool with the instructions received. In case of a mismatch, the cutting tool's position was first corrected, and then instructions to cut were released. Errors were prevented from occurring and detected at inception itself. This was totally a game changer and a revolution in the field of manufacturing. You could now have large-scale precision manufacturing that was sustainable. This brought prices of automobiles, refrigerators, washing machines, and most appliances within reach of many. Such game-changing technologies were invented for machines by us, humans. With over 50 years of flawless performance, that too sustainably, it was now time to simulate these technologies for similar performance back in humans. Ray Kurzweil, the computer scientist and director of engineering at Google, in his book Singularity is Near, explains his compelling theory of an exponential growth in computing and nanotechnology. To illustrate, says Kurzweil, what took 100 years to develop in the yesteryears would now take less than 20. And this is abundantly substantiated in the innovative research development persistence based upon sheer necessity at a services firm in Des Moines, Iowa. The need to overcome harsh economic conditions led to this service firm to research and development in search of technologies whereby their knowledge workers could now perform, hopefully, flawlessly and sustainably, just as CNC machines did. Development of this technology was, however, done under extreme conditions. Economic conditions were so tight that neither projects nor jobs were available. Their long association and concern for mutual welfare ruled out any form of a closure. This would generate hardship and misery amongst the colleagues. However, with their excellent reputation and goodwill, they managed to get a few projects, but at break even or at cost, but definitely without any profit. The overhead content of the fee at least provided them with salaries, rent and petrol bills. This would see them through these tough times. With such a bare-bone contracted fees, there was no room for project managers. More important, there was no room for errors which are always insured by profit margins, of which there were none. Hence, the compulsion for each individual to perform near flawlessly, and that too sustainably, since the projects had a duration ranging from 6 months to 3 years. Their need to jointly tide over these difficult times and conditions brought them a team of 40 together like never before. With such commitment, their homegrown technologies generated impressive results. The CNC machine simulation and the algorithms and equations enabled near flawless and sustainable performance, that too from each individual. Here are some of the results. Such consistent good and error-free performance generated an exceptional talent bank and internal leadership. These provided exceptional quality of service as can be expected, and hence many a global client put their requirement on hold, awaiting their project to be included by this team. This capability of bringing out the best within each individual attracted the very best talent in the United States, and this technology enabled the inventors to affirm a position at the very top in their field. Their invention had enabled the 3 most sought-after goals of any enterprise: to have and to attract the finest talent, to consistently provide excellent service, and then to have and to attract the most desirable clients in each segment of their business. The next section of this presentation illustrates the global game-changing technology they adapted and simulated to achieve such flawless and consistent machine-like performance in knowledge workers, then the challenges faced and the workarounds, and then links to Google Knowledge Base and the United States Patent Office detailing the entire mathematics, equations and algorithms for any services industry to simulate the same.